Hi, in Module 4, we're going to talk about some background information I think is going to be relevant and help you guys out throughout the whole module. I want to kind of separate some pieces out so that you can understand and you can just go back to this module to get the strategies instead of having to dig through it on the individual lessons for the module. What we're going to look for is represent and solve proportional relationships in this module. You're going to be able to learn how to calculate unit rates from rates, so that's some of the background information we want to talk about. How do you represent constant rates of change given if you're a table of verbal description, which are like word problems, equations, and a graph. And lastly, determine the constant of proportionality in real-world situations. So again, given that word problem, and how can we figure that out? When we compare rate versus unit rate, we're looking at, for a rate, something per something, and that's when we compare two quantities measured in different units. So like if we do, say, miles and hours, okay? So there's mile. And unit rate is something per one. Now the difference here that we're going to see is that over here in rate, let's say I was going 60 miles in 2 hours, okay? But over here, it's something per one. So we're still going to compare miles to hours, but what I do is I take my 60 and I divide by 2. So I have this 60 divided by 2, and that's going to equal 30, okay? So it's 30 miles, and what we do, but we typically don't show, is that it's 1 hour. Well, what I'm saying is by what we don't show is we don't show this, because we're actually going to take down here, we're going to divide this by 2 also. So that's going to equal 1, and this is divided by 2. So if we take another look here at another example, what I've done is I've created the rate, okay, and let's use a can of soup, or soup here, and let's say you go to the store and it's $3 for 2 cans. How much does it cost for 1 can of soup? So we would take the $3 and we would divide that by 2 cans. And as I showed you before, I'm going to take my denominator. I'm going to take that, and 3 divided by 2 equals $1.50. And 2 divided by 2 is equal to 1 can. So soup will cost $1.50 per can, and that's what we call our unit rate. In this portion, we're going to show the relationship that exists between a table, a graph, and an equation. It's all things that we're going to be heading to. So we all have seen what a table looks like, okay? But some of the things that typically happen is that we usually, when we look at the top row of a table, this could be our x variable, and on the bottom row, this could be our y variable. But one thing to keep in mind is don't always assume that that's true. You always have to look at the variables, and the question to ask yourself is, which variable controls which variable? It's the same thing that goes on down here on a graph. As you remember, the graph, the x-axis is the independent variable, and the y-axis is the dependent variable. So your title would be here, okay? And then when we look at the equation, you guys are going to start getting used to looking at equations like this, y equals kx, where k is what we call the constant of proportionality. So by looking at the number that's in front of the x variable, the independent variable, you'll be able to tell what the unit rate is. You'll also be able to look at what the dependent variable is and the independent variable, and you can calculate out what the unit rate. So this goes back to what we showed you in the previous section, where we take something's on top, divide by what's on the bottom, and then that way we get our unit rate or our constant of proportionality. One last thing to talk about the constant of proportionality is that if we look at a graph, and I didn't draw a table here, but I'll know this is my x variable, that's my y, okay? But the line is considered proportional if it goes through the origin. So if you remember on your table, or on your graph, you have your x and your y, okay? And the origin is right here, right where those two come together. And that is your x and your y. It's how we did here. And it's also by the points 0, 0. So this is the x, this is the y. If you look on the table, when you see in your independent variable or the x, you have 0, and the dependent variable is 0. That means that you are proportional. If you're looking at an equation, so y equals kx from the last slide, if x is 0, so k times 0, that means y has to be 0. That means you have a proportional relationship. This is a key characteristic that you have to keep in mind, because when we start talking about proportional and non-proportional and looking at your tables and graphs and equations on how to determine the difference between those two. So use this as background information to help you guys out with Module 4, and I'll continue on with each of the lessons.